All right, so now we're going to, first off with this pen of data, we're going to make a histogram. So highlight that entire column just by clicking on the entire column B, and we're just going to do the weights. So insert a chart, and then we're going to wait for that to pop up. Make a histogram, and I want to really especially show what happens with this data because of the different weights. So go all the way down past column, past map, past other, and here we have a histogram chart. So there we have a histogram chart. What do we notice about this chart?
It's broken into two sections.
Broken into two sections. So what's a good word to describe this?
Bimodal.
Bimodal, definitely bimodal, and it looks like they are almost nearly half of them are between 2.3 and 2.6, and the other half are between 2.9 and 3.2. Anybody know why that is? Yeah.
At one point in history, they started making the pennies lighter because they were cheaper to make, not as heavy.
Yep.
Not out of copper anymore.
Right. So back, I believe it was in the early 80s, they stopped making pennies to be solid copper, and they did actually, I believe the ratio is 3% copper and 97% zinc, and zinc weighs less. So all of these pennies over here are made after 1980. They're made with zinc, and all of these are made with copper. All right, so that's what I wanted you to see with the penny data. Now we're going to figure out how to do the standard deviation. So I'm going to take this chart and move it off to the side for now. Okay, so in order to do the standard deviation, first thing I want you to do is get the average. Okay, so in this cell right here, D1, doesn't matter really where you put it. I want you to put equals average. Okay, and then you're going to click, hold on. Average, you need to open parentheses. Open parentheses, and then you're going to highlight an array. So for me, it's B2 all the way down to B31 probably. Yep. Okay, and then press enter. And go back all the way up to the top. You should get an average weight of 2.78. Okay, now in order to find the standard deviation by what we did by hand, we need that average because we have to take the x value and subtract the average from it. Okay, so in D2, I want you to write a formula equals this x value, 3.08, minus this value for D1. But don't press enter yet because we want to be able to click and drag this all the way down and copy it. And we want B2 to be changed to B3 and so on and so forth. But we want D1 to stay D1. So in order to do that, you need to put dollar signs before the D and before the 1. That'll freeze the row. And then putting it in front of the 1 will freeze the, it'll freeze, put it in front of the D will freeze the column D, and putting the dollar sign in front of the 1 will freeze the row 1. Okay, that way when we drag it down, that value for D does not get dragged down as well. Okay, so there we have that. Let's drag it all the way down. So drag it all the way down, and we should get it to pre-populate like that. Okay, notice I'm down here, the sum is 0. So if you keep it all highlighted, all of those sums should be 0 because you have some positive values and some negative values. That's just how that works. It's pretty cool because it's the mean. Okay, so we're subtracting from the mean. What was the next step we did when doing it by hand?
Square that number.
We squared that number. So in E2, we're going to take that number and we're going to square it. So that, in order to do that, we're going to say that equals D2 times, which is shift 8, times, and then the same cell again, D2. This time we want them both to drag down, so we're not going to put any dollar signs at all. We should get 0.09, and that makes sense. And in this column, we should get no negatives. They should all be positives. Okay? And notice we have a sum down here of 2.6714. All right, now we're getting pretty close to the variance. In fact, to get that sum into our spreadsheet, let's put that, I'm going to put that up here in F1. That equals the sum of, and then open parentheses, and I'm just going to type in the array. It's E2 colon E31, because I know there were 30 pennies. All right, and then that'll give us 2.6714. We've seen that before. Now, after that, what did we divide by?
N minus 1.
Divided by n minus 1. So in this case, that would be, we're going to say equals this cell divided by, well, we had 30, we're going to divide by 29. By 29, we get 0.092117, so on and so forth. All right. What did we call this, Madison? Before, we have not done the last step, so we're almost there. This is called the variance. So in fact, let me label this right here. This is variance. Okay, and then this one over here is the sum of y minus, I'm going to say, mean squared. Okay, so that's all right, and then now we're going to get the standard deviation by taking the square root. Standard deviation, and that equals, how do we do square root? I think it's SQRT. Yep, square root equals SQRT of this number. And I think you have to open parentheses and press enter, and we should get 0.303508. Okay, so that is our standard deviation. Okay, so that's how we do it by hand. Now, after doing that, I want to show you this, because if you're using a spreadsheet, you don't actually have to do all that math, all those formulas, but I wanted you to go through the exercise of doing it. Let's say we just want to get it off all by ourselves. We're going to type this formula equals standard deviation, which is stdev, standard deviation, and then we need to put an array of data, which is 3.08 all the way down, so B2 to B31. So this formula I'm showing you now is just a quick way of doing it, and not doing it the long way, and we should get something that matches. Yep, and it indeed does. 0.30350829. So what this does is the formula up here, stdev, has all of these steps already included in it. Okay, so that is how you find, you do these. How you also find the standard deviation, one by doing it by hand, and then the second way is just by using the formula.